Today is our third day in the study of transformations. We have already looked at reflections and translations, and so today we're going to take a look at rotations. Whenever we are rotating, we are going to be rotating around a point, point R, we'll call it, which is the center of rotation. And what we can think of it as, we can think of it like a spin. I'm going to draw a set of axes so I can explain a little bit about what's going to happen. All right, that's going to be our X and Y axis. And we are going to take some kind of geometric figure and spin it around a point. If, for example, my point that I was going to spin around was the origin, and I was going to spin it in a counterclockwise rotation, which when we're talking about angles, that's normally the way that an angle would open up. A 90-degree angle would be that type of a spin, where we're moving up and to the left. That's going to be what I'm thinking of about a 90 degrees counterclockwise, which is against the clock, counterclockwise. A 180-degree spin, I think you remember what 180 degrees, but that would be flipping it around backward. That's 180 degrees, or 180 degrees counterclockwise. And then sometimes we call it a 270-degree spin, 270 degrees, or in our case, since this is how our clock moves, is down, we're going to call that 90 degrees clockwise. And that, in my picture that I just drew, that would be if our center of rotation was the origin. That's why I put that little R in there. So that kind of gives you an idea of how the spins are going to work. We have rules for these three basic types of spins that will make it very easy for you to figure out where the points go. We're actually going to give you a routine or a rule to follow, okay? And we'll do one at a time. So first one is 90 degrees counterclockwise. 90 degrees counterclockwise. That's the one that is going to spin down or against the way a clock is going to move, okay? So we're going to move, it was that first arrow I drew, that blue arrow that went up, not down, but up as we spun around. On a 90-degree counterclockwise rotation, we'll take the original X and Y, and in that transformation, we're going to trade the X and Y coordinates, but more than that, we'll negate the Y coordinate, and it becomes the new X, and the old X becomes the new Y. Here's an example. If the original point was 3, 1, in a 90 degrees counterclockwise, we'll take the 1, the Y, we'll change the sign on it, so negate it. It becomes our X, and the old X, the 3, gets put in the Y position instead. And what we're going to do is we're just going to follow that routine. Right, so I'm going to go one at a time on these. So let me go to the first example. A rotation of 90 degrees counterclockwise around the origin. On these, you are going to want to write down your points. It's going to get way too confusing if we don't do the transformation on each one. So let's figure out the coordinates of our points. A is -4, 5. B is, let's see, that's 1 to the right and up 6. C is 3 to the left, so -3 and down 1. And D is 2 to the right, up 1. Now let's do our transformation on that. Since we are going to rotate it 90 degrees counterclockwise. We're not going to think about spinning anything. We're going to follow our rule. Remember, the rule was xy becomes negative y comma x. And we're just going to follow that rule. So for A prime, first it's the opposite of whatever y is, so negative 5, and write down the old x, negative 4. For B prime, it's the opposite of whatever y was in the original point, so negative 6, and write down our x, 1. For C prime, it's the opposite of the original y. Opposite of negative 1 is positive 1. Write down the x. And for D prime, the opposite of the original y, negative 1. Write down the old x. Those are our 4 points that we're going to graph. So let me do some counting and we'll get our points where they belong. 2, 3, 4, 5 to the left, 4 down. And there's our A prime. B prime is 6 to the left, up 1. B prime. C prime is 1 to the right, down 3. And D prime is 1 to the left, up 2. Make sure you are labeling all your points and connect the dots in the same order they were connected in the original figure. So connect A to C, C to D, D to B, and B to A. Again, a rigid motion. The shape doesn't change, its position changes. And that's the rotation counterclockwise 90 degrees. Again, you're following a rule. All right, let's try the 90 degrees clockwise motion. 90 degrees clockwise. Here's the rule for that one. The original x and y is going to be transformed by changing the x and y again, but this time the y becomes the x but does not change in sign. The x value is going to be the opposite when we put it in its y position. So here's an example. Let's take that 3, 1 again. Let's say that is your original point. The new x is the old y, so the 1, and the new y is the opposite of the original x. So it goes to the point 1, negative 3. Make sure you're writing these in your notes as you go so you will have the rules to follow when you do the exercises. Okay, let's go to the second example. Example 2 is a rotation 90 degrees clockwise, and so we can keep track of what's going on. First thing I'm going to do is write down what the rule is. So xy is going to become y negative x. So I know the rule I'm going to follow. Then we're going to write down our points. Point P is negative 1 up, looks like 4. So negative 1, 4. Point Q is 2, negative 2. And point R is 1, 2, 3, 4, negative 4, negative 1. And again, all you're doing there is counting, just counting. Let's do our transformations. Here we go. To get P prime, it says take the y, that becomes our x coordinates. So I'm going to put the 4 first. Then look at the old x, the negative 1, change the sign. So it becomes a positive 1. And P prime is 4, 1. 1, 2, 3, 4, 1. I'm going to go ahead and graph these as we go because it's only 3 points. There's P prime. Q prime. Our rule says to write down the y coordinate, the old y from our original point, and then take the original x and change the sign. So it becomes a -2, and we'll graph the point -2, -2, and that is Q prime. And then finally R prime, the original y is -1, and the opposite of the original x is a +4, and we graph that point, -1, 1, 2, 3, 4. That's interesting. The new R prime falls right on top of the old P, and that's okay. Let's play connect the dots. R and Q were connected, so I'm going to connect R prime and Q prime. R and P were connected, so I'll connect R prime and P prime. And Q and P were connected, so we'll connect Q prime and P prime. Again, a rigid motion. We don't change any shape or size. We just rotate the figure 90 degrees clockwise about the origin. Once again, make sure you have written down that rule so you will have it to follow. The final rotation that we are going to take a look at and have a rule for is 180 degrees. And that is the same as 180 degrees counterclockwise. 180 degrees counterclockwise. So here's the rule. We're taking the original xy, x comma y, and to transform it, we aren't going to change any orders, but we are going to take the opposite of both coordinates. So if we go back to our original point of 3, 1, our first example, when we transform it, it becomes -3, -1. One last time, make sure you write down those 3 rules, because that's what you will be following on every one of your problems. All right, third example. Let's do one of those rotations. Rotation 180 degrees about the origin. So I don't forget it, first thing I'm going to do is I'm going to write down the rule. xy becomes -x, -y. Then I'll write down my 3 points, the coordinates. Take a little counting. 1, 2, 3, 4A is -4. 1, 2, 3, 4, 5. -4, +5. B is going to be -6, -1. And C is -1, 0. Let's do the transformations. The new point for A is A prime, and the rule simply says leave the x and y numbers where they are, but change the sign. So the opposite of -4 is a +4. The opposite of +5 is -5. Let me go ahead and graph that point. +4, 1, 2, 3, 4, -5, 1, 2, 3, 4, 5. It's clear down here. There's A prime. For B prime, the opposite of both of those coordinates. So -6, -1 becomes +6, +1. 1, 2, 3, 4, 5, 6 to the right, up 1, and there is my B prime. And then finally for C prime, the opposite of -1 is 1, and the opposite of 0 is still 0. Remember, 0 is neither positive nor negative, so you can't very well change its sign. When we graph that point, it is on the x-axis. So 1 to the right, 0 up and down, and there is our C prime. Play connect the dots. A prime to B prime, B prime to C prime, and A prime to C prime. Again, a rigid motion. The size and shape does not change, only the rotation, the position of the figure changes. Now, to practice a little further, when we did the other transformations, we did those transformations in one order. We gave you the rule, you drew the figures, then we turned around and went backwards. So we're going to do the same thing here. Keep those rules where you can see them, folks, because that's what you're going to need to decide. Example 4 says, write the rule. Well, when we wrote the rules on the other two transformations, we compared 2 points that were easy to read. Doesn't matter which 2 points you read, it's easy ones to read. I think my Y's are simple, my W's are simple, it's totally up to you. The Z's are simple. Tell you what, let's do the Z's. Z is -1, and 1, 2, 3, -4. It was transformed. Now remember, that is x comma y. And z prime, and I'm just counting, 1, 2, 3, 4. It is 4 to the right and 1 down. Let's figure out what's happened. The original y became the x, so it got moved to the front. There's y, and we changed its sign. The -1 got put in the back, so x got moved back here. Again, we looked at, let me do it one more time. We looked at the -4. It got put in front, so I took the y and I moved it to the front, and then we changed the sign. So that's where the negative came from. And then we found the -1. It went to the back. It didn't change, so the x that was in front becomes in the second one. Now you compare it to the first box we wrote down, all those rules. And if you will notice, that is exactly the same rule that we had for rotation, and it is a rotation, so you have to say it because that identifies the spin, and then identify how many degrees, 90 degrees, and the direction, counterclockwise. When you're identifying a transformation, you have to say whether it's a rotation or reflection or a translation. So that's why we said rotation. How many degrees? What direction? But if you will take a set of points, translate it into x's and y's, then you'll be able to identify what happens. All right, the last thing we did with the other two types of transformations, we gave you points and not a graph to see if you could follow the rules. So we're going to do the same thing here. Let's see, it says write the coordinates of the image after a 90 degrees clockwise about the origin. All right, so let's write the rule. I'm going to go ahead and put my x, y over the points I have. And 90 degrees clockwise, if you refer to your notes, it says that we are going to transform that into y comma -x, or the opposite of x. So let's just follow the rule. A prime, it says put y first and the opposite of x next. So it becomes -2, -3. B prime, put the y first, the opposite of x, the opposite of 0 is still 0 because 0 doesn't have a sign. It's neither positive nor negative. Oops, sorry about that. And then finally C prime, follow the rule. It says y first, so -5. And the opposite of x, the opposite of -1 is a +1. And we have our points. If we would ask you to graph that, the original would be a triangle. The second, the one with the primes, the image would also be a triangle, but it would be rotated 90 degrees clockwise about the origin. All right, I think that'll be sufficient if you'll use these notes to help you with the assignment. It's a little shorter than the others. If you do not have a worksheet from class, just graph the graphs on graph paper. Anything that you don't need graph paper for, you're welcome to do it on regular paper and then submit it. If you are in quarantine, submit it via Canvas. Hope to see you soon.